Hello everyone, it's been a while since I made a video. Just want to quickly go over my HVAC Calcs little database program here. Again, this is a database I made for the FileMaker platform. To use this for free, of course, it can only be used on the FileMaker platform and on iOS devices on FileMaker Go. And that's free to download from the App Store. So you would need to download that first, and then there's a link in the description here at the top of my page for my public Dropbox folder, and you can download this or any other files you want for free and use them and enjoy them. There's also some companion Excel spreadsheets that have the bulk of these calculations, but not all of them. So it's been a while since I updated this, so let's take a quick look. Going down the left side, pricing. These are more for if you make deliveries and you have to price things. I have an oil business, so I use this for minimum gallons and pricing. We'll go through these quickly. Gallons. This is kind of works like a totalizer calculation. If you have a couple pieces of equipment and you want to see how much each one took without having to write it down, you can just quickly use this as you're filling each piece of equipment. Take a look at the totalizer, note the total gallons, and at the end, when you're done, you can print this out. You can send it as a PDF or to yourself to include with billing and things like that. Delivery by time is used when you're making deliveries to generators in sequences. You want to maximize your deliveries and see how many gallons it's going to make and forecast when you need another fill up before it runs out. Tank volumes. You can put in any type of tank I use for fueling. There's horizontal, there's 7 different types. You can pick a tank. I do have some preset sizes in here, or you can add your own. We'll pick a 1,000-gallon tank, and basically you put in how much is in there right now. If you stick the tank, let's say there's 18 inches, and it'll tell you how much the volume is, how much the total volume, how much till you fill it, how much do you fill it to a certain percentage. You can select your percentage. I have 90% selected there. And that's it for tank volumes, basically. Pump pressures used for oil burners. You can put in your nozzle size. Many of the older specs spec 100 psi, and this will show you your flow rate, which in this case is 1.25 gallons per hour. And you'll see all the other nozzle sizes you can use and how you would adjust your pump pressure to achieve that same flow rate. Then down at the bottom, you can put in your type of heating oil, the efficiency of the appliance, and you'll find out your true firing rate, your BTU output. You can also calculate for true efficiency, which is basically used by oxygen and stack temperature. And you'll see in this case, even though this is your analyzer says 80%, you're actually only delivering 78% efficiency. Oil line calculator. This one I don't like this one too much, but when you're calculating how much usable oil line you can use for your oil burners, it's best to just consult the manufacturer's literature, because even though these calculations are accurate, some of them just don't make sense. And I went over them with a engineer at one of the major pump companies. He said, no, they're accurate, but they're kind of like the farther you get out of range, the more out of whack they are. So common sense for a lift and run, and the manufacturer's literature, I would just use those first. But this can come in handy. One of the little calculators here is how much your copper tubing will expand or contract based on the length and the temperature change. You'll see it's not really a whole lot, so that might also come in handy for you. We did oil line calculator conversion. There's a bunch of conversions on here. Decimal to construction tape, inches to millimeters, temperature conversions, pressure conversions, calculating domestic hot water needs when you know some variables there, and you can actually have a little stopwatch where you can clock it to see how many gallons per minute you're flowing, if you're trying to figure out why someone's running out of hot water, or if their fixtures are flowing too much water, no flow restrictions on them. You can calculate your heat strips for your heat pump at your different capacities, your design temperature, your certain capacities. You can calculate heat strips for the entire load, And there's the copper tubing expansion little calculator again there. Workflows, this is what's new. Looks rather complicated, but for what I like to do with this is you enter your information in the top as you come across it. You calculate your BTUs off your analyzer. You put in your temperature rise and your total external static pressure, filter drops, coil drops. Gives you you're checking your performance, and as a result, you can take a look at this, get all your results right here, and you can send that out as a PDF, or you can actually print it. So that does workflows. For oil, gas, I didn't do propane, and electric furnaces. For the boilers, you can, using if you have a flow meter, you can see how much you're delivering, how much your boiler is making BTUs, and how many it's actually delivering, and you can check it by zone and find out your boilers. Now, these numbers on this one are made up, so you're not really ever going to get 163% boiler efficiency, but I think you get the idea. Hydronics, a bunch of hydronic calculations, sensible heat calculations down the left side here. Temperature conversion, pressure conversion, just put it in another convenient spot. Sizing your expansion tank, sizing your portable expansion tanks, determining feet ahead based on flow rate and the pressure drop of a fitting. Down the right side, what do we got? You can clock a gas meter and find out your delivered BTUs. For heating oil, same thing. It was as we saw with the in the nozzle selection one. You can calculate your true efficiency, whether it's a condensing furnace or a condensing appliance or a non-condensing appliance. These are based on the calculations that came from Jim Davis, the late, unfortunately, and great Jim Davis, determining boiler efficiency, sizing a buffer tank, and a pipe volume calculator. And there's also more involved with this, but if you know, you select your pipe size, your length of your pipe, if you have glycol in it or not, and it'll just spit out all your numbers. This way, if you come across somebody's boiler system and you need to replace all the glycol, it turns out, I only need 6 gallons for this system. And then if you're mixing temperatures, you can calculate your mixed flow rate. Also in hydronics, we have hydronic system volumes. You can go through your hydronic system. You can go through every zone, measure up all the piping. You can add for boiler size, indirect, buffer. It does it all. You'll get a total amount of volume up in the upper left here. You'll see total volume of glycol, total amount of water, total amount of the entire system of water. Then on the right side, you're going to size your expansion tank for volume based on water, initial and maximum water temperatures, relief valve pressure, and height from the boiler gauge to the top of the highest radiation. And then all these could be, you can save this, you can print it out, or send it as a PDF. Same thing for circulator sizing. You're going to go through, put all your parameters on the left, and down the right side, you're going to put in all your, let's see if I have one more. Put in all your pipes, elbows, ball valves. I probably have a more advanced one here that I did. I think I did some on my house. And basically, over here on the left side, look at the bottom left, says circulator. You need a 6 GPM circulator and 12 feet ahead. That comes in handy. There's all these calculators are all online in various websites and by various manufacturers. But I like this one because I can put this on my phone, put this on my tablet. I don't need the Wi-Fi connection. I don't need a connection if I'm down in someone's basement, and I can do some quick calculations and help diagnose problems. I went over this before. This is pipe bending. If you bend copper tubing or electrical conduit, this is really great. This does all the calculations for you. I use a Rothenberger pipe bender, but what you would do if you have a different bender, you would go in here and go into where it says benders on the bottom, and you would enter your own bender, and you need to know the radius of the bender. So if you see this one here, it'll just say, for this one I have a 3 1/8 inch radius for my 3/4 inch tubing. And you just start putting in your measured lengths. I have a full video on how to do all different types of things with this. but it just gives you all the calculations. You can basically just take a piece of copper, pull your tape measure from one end to the other, make all your marks, as you see on the left side here. Stick it in the bender, one bend at a time. Just push through and keep bending. You don't have to take the pipe out, put it back on the wall, mark off the next spot. It just does it all. And it helps. On the right side here, you can see basic triangle calculations for simple offsets, 3 and 4 point saddles. You got parallel offsets here. You have rolling offsets. And there's another thing of some conversions for some easy math. I added these two also in my electrical calculations database, but we have an Ohm's law calculator where you enter in any two values and it'll spit out all the rest. Calculate wire length. If you have a spool of wire, you don't know how long it is, right? You don't want to unroll it, obviously. But if you have some thermostat wire and you want to and you want to find out how long it is before if you have enough, just bring this on in here. You're going to measure your ohms, and it'll tell you how much wire is on that spool. About. It's not perfect, of course. Down the right side here, the approach method. This I don't really use much anymore. With using probes now, wireless probes, and like I use FieldPiece, so the FieldPiece app or the MeasureQuick app, it'll do all those things for you. I initially made this when I was using a manual analog manifold. And this is the basic approach method that came out with by Lennox. Without gauging up, you would just put all your take all your temperatures and your airflow readings, and it would tell you whether you needed to gauge up and if you had a problem. So you might, if you're still doing analog, you might find this handy that everything's in one spot. Airflow, efficiency, psychrometrics. This is all airflow stuff. All your sensible heat calculations down the left, clocking a gas meter, adjusting manifold pressure for BTUs, content of heating oil. We've seen that already, calculating true efficiency, and some mixed air calculations. Down the right side, we have a psychrometric calculator, putting in your dry bulb and your humidity and your altitude, giving you all these numbers, putting your design CFM and your actual CFM, and it'll spit out a whole bunch of numbers here. This is sample data, and then I think you can just that's telling your how much moisture you're removing. I think. Yep, points. Yep. Here's some evaporator coil enthalpy, filter phase calculations. Duct traverse. If you use like a hot wire anemometer or a pitot tube, you can go in here and you've seen that chart. I'm sure it tells you, you put in certain parameters and tells you all the places that you want to check and make your drill. It's your drill points. And I just did for a round duct, put in your outside diameter, and this will tell you every place you want to drill along the circumference. You have drill point 2, drill point 3, and it's in metric and decimal and imperial measurements. And then at the bottom is your insertion depth. So in this case, with this, you would drill one hole, then you would drill another hole 6 and 5/16 around another hole at 12 and 9/16. And in those holes, I use millimeters because it's just so much easier. But you would just you'd stick your probe in at 6 millimeters, record 23, 47, 66, and so on. And that's how you would traverse a round duct. If you're doing a rectangular duct, same kind of thing. Put your length and your inside width and your inside length. It'll give you your drill points and your insertion points. It's calculating duct loss. Not too happy with this. It does work, but I would rather just use more advanced methods. But it will get you close. This is if you're using a pitot tube and you want to calculate CFM, and you put all your pitot tube measurements in there, and then that would calculate your CFM for you. And then of course you want to adjust that for temperature and altitude. Down here you can calculate SEER with your meter. If you have a meter, it does power factor, your SEER and your EER. and you can calculate your CFM for electric heat. Refrigerant and charging. This you can find everywhere, but this is for additional. Down the left side, if you want to, these are all more manual measurements. Again, you can use wireless probes and FieldPiece app or MeasureQuick app or whatever app you use with your wireless probes. But this is calculating targeting superheat and how, if you want to add or remove refrigerant, if you're targeting subcooling, if you're measuring delta T across an evaporator coil, if you're calculating your target evaporator delta T, and calculating your compressor ratio. On the right side, you got additional charging rules of thumb for most refrigerants. This one is if the manufacturer specifically gives you the additional charges, you put that in there, and it'll tell you how much you need to add. And then calculating nitrogen pressure test, pressure temperature compensated nitrogen test. Put all those information and tell you if you're passing or failing. Recovery tank, this is basic stuff here. This will tell you how much you can put into a tank, how much room you have, and how much you have left. Based it on 80% and 130 degrees. Capacitors, this is for checking capacitors under load. If you had a 440 volt, 35, let's say 5% plus or minus. Oh, I lost my microphone. I didn't enter that. 35. And then you read 6 amps. And you measure 363 volts, we'll say. Your capacitor failed. And it shows you what parallel and series microfarads if you have to combine capacitors. And there's the capacitor charts in here if you need to see that also. That's capacitors and combustion air requirements for fossil fuel burning appliances. If you're getting all your air from the outside, you check that box, enter the size of your room. It'll tell you what's available. You enter all your BTUs from your appliances, and it'll tell you, give you information. If you're going not from the outside, it'll show you in a combined space. And then if you're getting your additional air from outside the building, how much more air you need to bring in. If you're getting it from the inside of the building, how much air you need to bring in. And that's basically it. That's basically the condition of the HVAC Calcs app as of right now. And again, that's free to use. At the top of my YouTube channel shows you the link for the public Dropbox. If you have any questions, any comments, if you find any calculations wrong or anything you'd like me to add, please feel free to leave me comments. I appreciate it. Thank you.